Hello future tech leaders, I am Sindhuja. Based on my own experience, I know that learning the right skills can shape our future. What if I say learning was as thrilled as the tech world itself? There we go. A cloud foundation, that's exactly what you will experience. From day one, you will be immersed in the interactive sessions and expert-led courses that covers most of the widely used technologies in the zone of data science to cloud computing, which brings more light to the life of a techie. I'm so excited to help you and unlock the true potential of a technology. Well, then why to wait? Let's see what it unfolds.
Let's go to the next member here, which is Azure Front Door Service. Most of these features that you'll see most of these resources that you'll see are similar to your application gateway, right? What is the difference over here? As far as the core difference that you'll see is, this is primarily targeting towards web-based resources, right? And it can help you with global routing. URL-based routing, multi-site routing, your TLS termination, right? What it can help you do is it can help you work with number of Azure resources in different regions. Layer 7 and Layer 4. That's right. As front door service is concerned, front doors basically works on Layer 7. That is IP. That is your application layer. Another option that you have, that is Azure Traffic Manager. As part of Traffic Manager, this is one of the most important resources which Microsoft has been providing for a very long time. Initial phases, even when people were going for Azure migration. Hybrid setup of resources or using their solutions. Where if the on-premises environment is not working, then it should connect to your Azure environment. Right. All those kind of scenarios has been implemented successfully by using Traffic Manager. Even if you are using a web-based application and you want to have a load balancing or DR solution, you can use Application Gateway as well. Now, as part of Traffic Manager, like how you have back-end pool, similarly, here you have something called as endpoints. Within your resources here, what we can do is we can specify endpoints over here. Now, these endpoints will be mapped to your Traffic Manager. Traffic Manager will have a DNS. This is this tool or this service that you see traffic management. This is basically an endpoint management tool and which uses DNS-based configuration. If you look at your Azure Load Balancer or if you look at Application Gateway, they support both these kind of resources. They support public, IP, they support DNS. But once it comes to Traffic Manager, this is a DNS-based service. It will not support anything which does not have a DNS. Even if you want to associate public IP over here, you need to have a DNS associated with it. Without that, it will not work. Right? You can associate this with your virtual machine scale sets. Or you can also associate with your app service. The diagram over here shows app service. It can work with VMs also. There is no problem with it. But that VM should have a public IP and that public IP should be associated with a DNS. That's it. Now, one of the important aspects that differentiates it from the other members. Here you have multiple routing methods you have number of routing algorithms. You will have priority-based routing, weighted routing, geographical routing, performance-based routing. There are different routing methods over here, which differentiates Traffic Manager from other members. As an architect, or if you look at your exam perspective, whenever there are questions, you will have to understand what is the kind of requirement that we have. And based on that requirement, which will be the most appropriate solution over here. Which will be the most appropriate solution here. Whether this given problem can be solved by front door, it can be solved by application gateway, whether it can be solved by Azure load balancer, or you may need to have combination of some of these members. Even that is possible. It's not that only one solution should be used. You can use combination of these solutions as well. Remember yesterday I have shared a link with you all where it was helping us decide when to use what. Those are things you should have practiced. Then tried it yourself. It becomes easier for you to select that right option or in real world scenarios, do that actual processes. In terms of priority-based routing, what you would have done over here is you would have specified priority value for each of these endpoints. And depending upon, say for example, the first member is down, which has a priority as 1. Right. What is the next priority in sequence? It will connect to the second member with the next priority level. Now you could decide this priority based on any number of parameters. Those things are not mentioned over here. Those things are not part of this decision. That how are you making it second priority or third party? That's your choice. Because you, as an administrator, would know the response time of each of these members. Second option here is performance-based routing. When as an admin you are not clear, what Traffic Manager can do is, it can send ping messages to these endpoints and depending upon how much time it takes to respond for each of these endpoints, it will connect to those endpoints over here. Third member that you see is geographic routing. Depending upon what is the geographical location that you have and where is the user request coming from, whichever is the nearest location, it will start mapping to that endpoint. Now, if you see this diagram, it shows something called as nested profiles as well. Whenever you have a complex scenario, you can make use of a nested profile, which means there can be communication or one of the components of Traffic Manager would be another Traffic Manager. In that way, we can solve two problems. One problem is like the solution is showing in terms of geographical routing. Second solution that we can create over here is you can use multiple algorithms. Now somebody would say, I would want priority-based routing. Plus, I would also want performance-based routing. I want to use both these routing methods in the same environment. You can do that. You can use something called as nested profiles over here. Similar to priority, you have something called as weighted routing. Weightage-based routing. How much weightage you are giving to it. Based on weightage, you can prioritize which members you want to communicate. or which resources you want to connect to it. Before we go for comparison, let's show you implementation of this. This is little bit included. Let's proceed further. As part of Traffic Manager, here you have something called as Traffic Manager Profiles. Let's go to Profiles. Quick confirmation. If in case we want all these routing options, what you are saying, we this Traffic Manager with combination of gateway, the load balancers, kind of. If I look at the Traffic Manager, right? Now this Traffic Manager, it's a DNS-based endpoints, which means I can go ahead, create. Once it comes to Traffic Manager, behind that I can create Azure Load Balancer with public endpoint. I can go ahead, create. You guys use the Traffic Manager. You guys use often word. Where you work. Out. Just one moment. When she as far as this Traffic Manager is concerned, this is something which is customer facing or using Traffic Manager. This is customer facing. Now behind the scene, what it needs is when you are configuring these endpoints, you need it. Now this DNS could be a gateway, load balancer. It could be your app gateway or could be load balancer. It doesn't matter for Traffic Manager. It should be just a DNS. That's it. What is mapping the DNS behind it? How that public IP is coming? It doesn't matter. Does it answer your question? But I thought like gateway will be the gateway. Load balancer will be the customer facing and inside. We are managing the traffic based on my routing options like priority or performance. Something like that. Is that possible? You are saying application gate phase. I have not seen such kind of architectures where Traffic Manager is in the back end. Just why I am saying that some of these things, when it comes to architectural questions, it becomes easier to answer them. Showing a diagram that will help. This is the right one. This is the right one. It is not here. If I go to the product section, sync, management and governments. Let me go to Azure Site Recovery. And let's see this diagram. Now, this is what I was talking about. Can you see Traffic Manager over here? When customer is connected to Traffic Manager, this Traffic Manager can connect to two set of endpoints. This endpoint will have the primary site, and instead of this load balancer, I could have an application gateway here. Getting it? If this site itself goes down, then you will connect to a secondary site from a DR solution. And what? If you look at from a larger perspective, Chen, I think this should answer your question as well. Depending upon what is the user looking at. Is the user looking at a DR solution, CDR solution, or are they looking at a single endpoint? In most of my scenarios, where people are, we suggest them to go for a DR solution. In case the primary site goes down, you have a failover mechanism for yourself. If they agree to that, we go for Traffic Manager. If they are saying no, we don't want failover, we don't want BCDR right now, we would want BCDR later, we still create Traffic Manager. Just have N1 endpoint right now. A communication will come to Traffic Manager, and from Traffic Manager will come to the primary site. In future, if I want to add a secondary site, I have an option already create for me. I just create a secondary site, which is passive right now. I also see that endpoint over there. Let's proceed further. Let's take up our Traffic Manager profile. Let's put this in a resource group. Can you see this? It does not allow you to specify your location. Because it's a global service, you don't have a location for it. Let's go ahead. Click on Create. Once you have your profile created, now what we need to do is, we need to go ahead and do the configuration here. Within configuration. So, not configuration. Endpoint. Configuration will be required if you want to change any of the attributes or properties in terms of endpoints. Here we are supposed to add an endpoint. In terms of Azure endpoints. In terms of Azure endpoints. In terms of Azure endpoints. Azure endpoints. In terms of Azure endpoints, it can be a public IP address. It can be an app service slot. Can you see this? Even if I have a public IP address, and if I have a public IP address with no DNS associated, it gives an error. You are giving me a public IP, but it doesn't have a DNS. Any resource that you are mentioning over here. Cloud service, app service, app service, app service slot. Anything that you are associating should have a DNS. That's a primary requirement for traffic management. App service. Whenever you are adding an endpoint, does it make sense to everyone? Whatever app we have created right now is more like application gateway or your Azure load balancer without a backend pool. Once you create your resources, you can keep adding your members over here. You can keep adding your resources here. That's a core purpose of traffic management. I think yesterday somebody asked a question. Have we created web application? We will come to that section. And there, some of these resources I will add as part of the endpoints for traffic management. If you look at the decision tree, or if you look at the chart over here, this will help you define in which scenarios, which service, which of these load balancing options can be used. If you look at your Azure load balancer, this is meant for region specific or environment specific implementation. When I say region specific, within a given region, you have 3 to 4 VMins segregated to separate subnets. That's where we'll use Azure load balancer. Right. Set dumps of protocol, base protocol, T. And it will not work with app services. It will. No PaaS service support, only for infrastructure as a service components. It can connect to your on-premises environment by using site-to-site connectivity. You'll have to first configure that. Without that, you will not be able to use Azure Load Balancer for your on-premises environment. Even if it mentions internal and external, you should understand how this will work. How can communicate with external components? Even external components over here will not mean AWS resources or other members over here on premises environment where we have site-to-site connectivity. In terms of application gateway, this is level 7, which is application layer. Now this one supports many more members. Azure scale set also support host name, right? Your app services. This can help you integrate with your on-premises environment using site-to-site connectivity. Even if you have non-Azure resources, it can communicate with that as well. If you look at Traffic Manager is more external facing. Why is it external facing? Because it requires DNS. Every communication is happening over public in public network. I hope that is what we understood while you are discussing that since it is working on an external layer or an external DNS, putting it inside an environment does not make sense. Putting inside a service layer or application layer or data access layer does not make sense. Because anyways, by the time it reaches the data access layer, it has to be a DNS or a public IP, so private IP based resource. And in those scenarios, Traffic Manager does not work. It works more on the presentation layer and the external surface or the external components of your architecture. Here, if you see, this is very much similar to your application gateway in terms of the backend pools and pointed supports. Application gateway can work directly with public IP addresses or IP VLAN. Traffic Manager needs DNS. If you look at your front door service, your liaison, you can see I can make it work with internet-facing services. This is one of the very important aspects. It will not work with IP addresses, host name, none of these. It has to be an internet-facing service. HTTP. If you have your services, it can work with services, but it has to be internet-facing. That's the important aspect of Azure Front Door Service. It cannot have any communications with your on-premises environment. That kind of implementation is not supported over here. Does this help you understand? In terms of network traffic, we have understood about the options over here. And finally, do not forget to like, share and subscribe to our channel.